Okay, there's another facility that Java provides that leads to very elegant and compact client code that's definitely worthwhile to add to our basic data types, and that's iteration. That's what we're going to talk about now. So what we want to do is to allow the client to iterate through the items in the collection. But we don't want the client to know whether we're using an array or a linked list or whatever internal representation we might have in mind. It's not relevant to the client. In a lot of clients, all they want to do is just iterate through the stuff in the collection. Now, Java does provide a nice solution to this called iteration. So what we're going to do is look at how to make our stack and queue and other data structures that we consider later on implement the so-called iterable interface. And it'll work for client code no matter which implementation we use. So let's take a look at the details of that. So what's an iterable? In Java lingo, what an iterable is, it's a class that has a method that returns an iterator. And so what's an iterator? Well, an iterator is a class that has methods has next and next. The Java also allows remove. We think that one is bad news, so we don't use it. It can lead to insidious debugging problems. So has next and next. And so to make a data structure iterable, we're going to implement those things. And it seems like a lot of baggage to carry around. And the reason that we do it, why we go to the trouble of doing it, is that we can, if we have a data structure that's iterable, we can use a very compact and elegant client code in Java, the so-called for each statement. So if we have a stack, we can say for string s colon stack, it means for each string in the stack, print it out. And if we didn't have that, we would, if we're using iterators, we could go ahead and write this longhand code, but nobody would ever do that because it's equivalent to this shorthand. Or we might have to write client code that does a lot of unnecessary pushes and pops just to do this iteration. So that's the key, is to be able to have client code that is so compact for iterating through items in the data structure. So we're going to provide iteration for all our basic data structures. And it's not too hard to do. Definitely worthwhile the effort. So here's what it looks like for linked lists. It's got to implement iterable. So what does that mean, implement iterable? It's got to have a method iterator that returns an iterator. What's an iterator? So we're going to use an iter class. In this case, we'll call it list iterator that implements iterator, and it's generic. And basically what this thing has to do is implement these methods has next and next. And the semantics is clear from the names. Has next is supposed to, if we're done, it's supposed to return false. If we're not done, it's supposed to return true. And the next is supposed to give the next item in the iteration. So if the thing is a linked list, we're going to start out at first. That's our first item in the list, and we're going to maintain an instance variable current inside this iterator, which is the current thing that we're iterating. So to get the next one, just like when we remove the first, we pull out the current item and then advance the current reference and return item, moving current to the next place. The client is always going to be testing has next, as I showed in that stub code before. And so when it gets to null, it'll return false, and the iteration will stop. But for our iteration, we just have to worry about implementing next and has next, and perhaps using a local instance variable to get it done. We have to probably, to make bulletproof code, throw exceptions if a client tries to call next with no items there, or tries to call remove at all. We're not going to support remove. And for array, it's even simpler. Now the iterator, we have control over which order we go through the items, and so that's going to go along with the semantics of the data structure. So probably in a stack, you want to get the things in stack order, like the order that come out of the stack, so that's reverse order in the array. In this case, then next is just decrement and return the next one, and our instance variable is an index in the array, and then has next is okay as long as that thing is positive. A little Java code to provide this iteration facility, but actually within this framework, not too much to do, and you can see how to implement this for your own data types, and we'll use this paradigm for every basic data type that we that involves collections of objects that we'll encounter. All right, and in fact, that leads us to actually, for a lot of clients, it doesn't really matter what order we get the items. Really, often what we're doing is just inserting items into a collection, and then later on iterating through the items that we have. That data structure is called a bag. So let's look at what that API looks like. The order doesn't matter, so all we're going to do is add an item. Maybe we want to know the size, and we want to iterate through all the items in the bag. So this is a simpler, narrower API, but still it expresses an important little collection of operations, and we'll use this one. We've already seen the implementations. You just take stack and remove the pop, or queue and remove the dequeue, and you have a fine implementation of a useful data structure.